Hi, let's take a look at one application of chain rule. One example of chain rule we use is in polar coordinates. For example, let's say the function w, which is a function of x and y, which you got x squared plus y squared times xy, and x and y are in terms of their polar coordinates. Now, I'm going to rewrite w by distributing. This becomes, of course, x cubed y plus x y cubed. Just makes it a little bit easier for us what we do later on. Now remember, in place of x we have this r cosine theta, and in place of y we have this r sine theta. So for our first example, it says we want to find how w changes if we only look in terms of r. So we want to find the partial of w with respect to r. This is our chain rule because remember, I'm looking at w, which is a function of x and y, but I'm substituting in my r, my x and my y into these. So that's how we get this chain rule right here. So to do this, we're going to take the partial of w with respect to x, multiply by the partial of x with respect to r, and we do the same thing with the y's. Partial of w with respect to y times the partial of y with respect to r. And when we do this, what would we get here? We would take the partial of x, w with respect to x. So I take this derivative here with respect to x. This is y distributed, so I have to worry about product rule. And we would get 3x squared. We would get 3x squared y plus, and this just becomes y cubed times, now the derivative of x with respect to r, that just becomes cosine theta, plus the partial of w with respect to y, so this becomes this x cubed plus this becomes 3x y squared, and then we're going to multiply that derivative by y with respect to r, and that just becomes sine of theta right here. And there is our derivative. Now, of course, you can replace if you want to. All right. For example number 2, we want to find the total derivative partial of y, w with respect to r and theta. So now we're going to do our total derivative with respect to all of them. So now we have to do those multiple variables. So the partial w, derivative w, is going to equal, well, we have to deal with, let's deal with r's first, or the x's first. So you can deal with r's or x's. I like to deal with the x's first. So we get the partial of w with respect to x times the partial of x with respect to r. Or plus, now, whoops, I'm sorry, that should be just dr, excuse me, and this becomes the partial of w with respect to y, with respect to x, let's do d theta. So now remember, taking the derivative of w with respect to x times its rate of change in the r, and then we do the same thing with the term, how it changes in theta. Plus, now we do the y, the partial of w with respect to y times dr, plus the partial of w with respect to y, d theta. And there is our total derivative in terms of change in r and change in theta right there. Alright, now the next one, question 3 says, ask to evaluate the derivative, the partial of w with respect to r at this point, where they say r theta. Now notice they're giving me r and theta right here. So we are going to use, we have to use our equation from part 1. Where we're saying r is 2 and theta is pi over 4. So we have two options right here. So I got to plug in, so anywhere I see an r, I'm going to plug in a 2, and anywhere I see a theta, of course, I'll plug in pi over 4. But notice we also have these x's and y's. So I have a choice. I could just replace each x and y with r cosine theta, r sine theta respectively, or I can just find out what x equals to. X, they tell me, is equal to r, so 2 cosine theta, and y was equal to 2 sine pi over 4. So that's 2 root 2 over 2, or just root 2. And of course, this is 2 root 2 over 2, or just root 2. and you would just plug those in right here. The one I want to take a look at is question number 4, where they say find the partial of w with respect to theta. So now we're looking at the derivative with respect to theta. Now up here we took the derivative with respect to r. So now let's take the derivative with respect to theta. So this is going to be our chain rule again. The partial of w with respect to theta is the partial of w with respect to x times the partial of x with respect to theta. See, we're creating a formula for us. It's going to tell us exactly what we have to do. We get the partial of w now with respect to y times the partial of y with respect to theta. And I can get this. We already know what the derivative of w with respect to x is. That was just 3x squared y plus y cubed. And we're going to multiply that. And we're going to multiply that by the derivative of x with respect to theta. And that's going to give us negative r sine theta. So this is going to become times negative r sine theta. Plus the derivative of w with respect to y, which again we already have. That was just x cubed plus 3xy squared. And we're going to multiply that by the derivative of y with respect to theta. So y was r sine theta. So of course this becomes times r cosine theta. And there's our derivative. Now we have to plug in this point. So they give us x is negative 4, y is 4. So notice, that's easy. I got all my x's, but I still have these r's and thetas. So I have to find r and thetas. So we got to get a little trigalicious with it. We're at negative 4, negative 4. There we go. So I need to get theta right here. Well, obviously we're in the third quadrant, so theta is going to be 5 pi over 4. And r is just going to be the square root of 16 plus 16, which is root 32. So we got r, we got theta, we got x and y, and we can just plug those in to get our rate of change. All right. And our very last example here. All right, this is a good one right here. One that you could see on a test or a quiz or something along those lines. If we're moving about the line x plus y equals 7, solve for dw dr in terms of theta. Now notice we're looking for this in terms of theta right here. So we have to convert to polar. So if we have x plus y equals 7, well right away this is saying that r cosine theta plus r sine of theta equals 7. And I can solve for r right away. 7 over cosine theta plus sine theta. Okay? And then I'm going to take the derivative. So let's find our derivative. So let's see here. We already remember w was equal to this x cubed y plus xy cubed. I want to take the derivative with respect to r. So this is going to be our partial. So let's see here. Let's go ahead and convert this using our little formula right here, our x and y things. So let's see here. So we're going to convert this into polar as well. And that's going to give us r cubed cosine cubed theta. Whoops, sorry, y. It's going to give us, yeah, I was right, r cubed cosine cubed theta times y, which is r sine of theta, plus x, which is r cosine theta, times, what's this, r cubed sine cubed theta. And I can factor out a whole bunch of things right here. Okay, so let's see here. If we factor out a whole bunch of things, I can factor out, looks like an r to the 4th. And I can factor out, let's see what's that going to leave us. And I can factor out a cosine sine theta. So I can factor out a cosine theta, sine theta. And what's that going to leave us? That's going to leave me with a cosine squared theta plus a sine squared theta. Oh, that's always nice when that happens. So that just becomes 1 right there. So, whoo, that's nice. We escaped that bullet, right? So what we're left with is r to the 4th cosine theta sine theta. Now remember, we're looking for the partial of w with respect to r. So now I can take that derivative. That just becomes 4r cubed cosine theta sine theta. And recall, we solved for what r was. over here. So that's going to become 4 times r cubed, which becomes 7 cubed, on top cosine theta, sine theta, all over this bottom function cubed, because it's r cubed, right? So remember, it's r cubed. This becomes cosine theta plus sine theta cubed. And there we have our derivative right there. I hope you enjoyed that video as much as I enjoyed giving it, so enjoy. I'll see you guys later. Bye-bye.